Hello there. In this tutorial, I'm going to show and we're talking about the topologies. So different types of topologies are there. So what are the topologies? And it's really important topic in the networking lines, networking concepts. So topology is a pattern of network devices and describes the way in which these devices are connected. Topologies can be physical and logical. Physical topology refers to the actual physical structure of the network, while logical topology determines the way in which the data actually passes through the network from one device to other. So actually it's a form of topology, that how topologies actually form, how topologies actually install in our network is known as how the device is actually installed in our network is known as topology. So the group of devices are connected anyhow, it's connected in any way. So those that structure which these group of devices are connected were known as topologies. So topologies were a lot many types, but this is the thing, means the structure of a network, the structure of where the group of devices actually connected with each other, the way of the structure is known as topology. So types of topologies is single node, bus, star, ring, mesh, tree, hybrid. So when we're talking about the single node topologies, these are the types of topologies and the basics of topology. The single node is no more in any documentation. Single node is not even uh, there, but we could discuss about single node. We could include in the list, but then bus, star, ring, mesh, tree, hybrid. Single node topology. A single node topology network includes a single device which is connected to the server. The server is the main device that is used for network data storage. If a node does not contain files or information needed for operation, it is known as dumb terminal. Means, for example, a server is there and a client is there and directly connected with the network, or in the peer network also. Uh, if two client computers are connected with each other, one client computer will obviously have admin right. An admin already obviously it will operate the uh, all kind of rights and have uh, the rights to operate the network. So this is what single node topologies are all about. Now, definitely those devices were connected with each other, and all the time they synchronize the network. I mean, they all the time they keep refreshing themselves. But if the node does not contain files or information needed for operation, for example, if this cable not able to get the necessary file to operate each other, then it will be known as dumb terminal. By the name you can see dumb terminal mean for no use. The advantage of these single node topologies are easy to install, configure, manage, least expensive, as a dormant terminal is the cheapest computer. Just connect the network. A single cable is required, so it's the very cheapest thing to have as a network, and easy to install. Just pull out the cable, and no more extra device needed. Just pull out the cable in an IC of both computer and will become a network. The disadvantage is only a single device is connected to the entire network. Means this would be known as the entire network, won't be the different network. But If you want to connect extra computer, you have to just add more and more devices. So this is what the disadvantage. Dumb terminals depend on the server for resources. Means all the time, eh, since it don't have any resource on their server, will always believing and always considering to have data from resources or some resources. Bus topology device share a common backbone cable to send a receiver data. A thick this is what the bus topologies are, and common backbone cable to send and receive data. A thick coaxial cable used to connect all devices. So one thick coaxial cable will utilize to have a bus topologies, and then the bus topologies uses daisy chain scheme to add more devices in network. In this daisy chain scheme, device 1 is connected to 2, device 2 connected to 3, and then first and last connected to the 50 ohm terminator. This terminator created, for example, if this device 1 send the data, uh, distributed data, wants to send this sixth device, and that sixth device is out of order, not able to uh, working and not able to participate in the network, then this packet will keep on moving into the network, and at that same time, if device 2 sends some data and might be start colliding, means if this first packet keeps on moving here and there, and if the second device also send the packet, might be before it reached to the uh, sender's place, it might collide with that packet which not reached to the device 6. That's the reason Terminator created a 50 ohm resistor to absorb the packet if not used. So a device actually shares a common backbone cable to send and receive data. So that's the reason. I mean, send and receive data at the same cable, from the same cable. Then it might create a problem. The thick coaxial cable is used to connect all devices. So this is the cabling type. Now, many things there. The both bus topology, the server is connected at one end of the backbone cable, and the other devices were connected to a different position along with the backbone cable known as trunk. So, I mean, one device is connected to different position. I mean, this device is connected to this cable, and this device different positions are there, and the backbone cable and the device is connected or at different positions along with the backbone cable known as trunk. I mean, these are the different positions. So this cable will be known as trunk. The advantage are easy to connect device to a linear bus, require less cables, less expensive than other topologies. This is the practical topology. Works better for a smaller network. The disadvantage are entire network gets affected if there is a break in that main cable. I mean, if this cable get discarded, the entire network will be affected. Terminators are required at both ends of the backbone cable. I mean, if someone not wants that terminator, it could not have a terminator, but then it will affect the network badly. Difficult to detect the faulty device, because since Only thing is there that if you start pinging with each other, for example, if this device wants to ping with this 4, and for example this at the same time this device 5 is also get uh, out of order, then and if this device 1 tries to communicate with this device 6, then we might not able to recognize which one is actually not behaving, or we might start thinking that our own computer is not connected properly. So it's very difficult to detect. Limited number of devices can be attached. Uh, this is the disadvantage. Heavy traffic and addition of devices degrades the performance. That's another obvious reason, because if you keep on raising devices, and if the same cable will remain as a backbone, then will be hurt then never badly if a device get problem. The heavy traffic and the addition of devices degrades the problem performance, expensive than single node topologies. Okay, next topology known as star topology. Star topology are multiple devices connected to a central connection point known as hub or switch. Devices are attached to the hub by using either copper cables or fiber optic cables. So by diagram you can understand that either hub or switch represent these network, and the uh, or it be using copper cables and fiber optic cables. So these are the uh, basic structure of star topology. Also, what we are talking about these star topologies are is a cost-effective method for sharing information between different users, since not many devices will be connected. Also, your cable type will increase, your cable size will increase. Obvious reason, because you will find that not only each and every device is connected with the cable, so but also you need to purchase a centralization because it's a central connection point, so you need a centralization server kind of thing. So hub or switch, either if hub or switch goes out of order, then the whole network will start collapsed. This will be their disadvantage also. So advantages: easy to install, configure and manage, easy to defect faulty devices, easier to expand. Since hub or switch is connected, that's the reason the smartness is there to detect the problem of the network. Connecting or removing device does not affect the network. For example, if this device removed, the laptop removed, then also the network will continue like that. Hub provides a centralized management, but disadvantages: increased device causes traffic, which makes the network slow. That's obviously, and if you put uh, a server, a workstation, then might cause you uh, require more cable length, and then a linear topology. Hub failure leads to network failure. This is what I'm talking about. The hub or switch, it gets failed, the network will collapse. More expensive. That's okay. This is the disadvantage of star topology. The other topology we were talking about is ring topology. Now in ring topology, each device is connected to adjacent device, forming a circle. Data flows in only one direction, clockwise or anti-clockwise. Each device in the topology act as a repeater. So it doesn't matter how the device can flow from here to here. So clockwise or anti-clockwise doesn't matter. Uh, we're going to see how to going to uh, transfer the data. Um, so this is what the type of ring topology is all about. So also it will remain as a repeater. For example, if one device distribute the data all the time, then might be this fifth device distribute the data at anti-clockwise. So we will uh, behave as repeater. The advantages are easier to manage as compared to bus network, handles large volume of traffic, very reliable and offers great speed, provides good communication over long distance, no terminators are required. The great speed, why? Because there is no foundation. Device can connect it both anti-clockwise and clockwise direction simultaneously. That's the reason it offers a great speed. If packet not able to move from clockwise, then moves through anti-clockwise. So that's the reason why ring topology is a very advantageous thing. But disadvantage are more cables was compared to bus topologies require, since you will not sit or you will not form this ring topology in this small network. You have to expand the network, and these network is actually connected to big network. The physicality I'm talking about. One faulty device affect the entire network. Possible, for example, if this computer stop working, then might be with anti-clockwise we can travel, but then the packet circulation will not going to happen. It will reach the data. For example, this one device can reach to this two device, but will not complete the cycle, and that's the reason network might get affect. Addition and changes of devices can affect the network again, since it's a path following. That's the reason. But at the same time, the network packets will be run and distribute the packets. Now, ring also have a type. It's called dual ring, and every device will have a two network cables. So only advantage is that network will never goes down, and all the time will connect with each other. Since one cable get faulty or one device get faulty, then with another one, uh, since two NIC is required, so if one NIC get faulty, then with second NIC packet will keep on distributing and keep on moving. Only disadvantage would be the cost and the cable size of the cable. So in ring topology, single ring is used, where dual ring topology consists of two concentric rings, primary and secondary, to connect each other on a network. So if primary gets faulty, secondary will take over. The mesh topology. In mesh topology, each device is connected to every other network. Device can send data to all devices in the network. Data sent by the device can take any possible path to reach destination. So this is what the mesh topology is all about. Also, you can see a lot many ways are there to communicate with each other. At all, the computer have almost four places to move the device. So you can see this. For example, if you take this computer as an example, this computer can send data from here, from here, from here, from here, from here. Means almost four places, from almost four uh, places where you can send the packet. The type of mesh is full mesh and partial mesh. Now, when you're talking about the mesh topology, and when you're talking about the types of mesh topology, then you will find then In full mesh topology, each device is connected directly to each other. In partial mesh topology, some of the devices are connected to all others, but there are some devices which did not exchange data with all. Means doesn't matter it's connecting with each other, but it not distribute data with each other. Might be if we enable some security, uh, so it won't distribute data. So that's the reason partial mesh and full mesh will all the time distribute data to all computers in a network. Advantages provides a redundant path which help in sending data using an alternate path if a specific path fails to send the data. Entire network does not get affected by one faulty device. Centralized management is not required as in star topology. Easy to detect the faulty device. Disadvantages: more cabling is required as compared to bus, star, and ring topology. Each link from one device to another device requires an individual NIC. It means we require 4 NIC, which is again a costly matter. Very expensive compared to bus, star, ring topology. Data carrying uh, capacity is underutilized unless all devices are transmitting almost constantly. Otherwise, if any of the devices start uh, losing and start not able to provide data, there might be we can say network will get slow, difficult to reconfigure. It's too uh, you can see it's like a spider shell. So that's the reason it's very difficult to reconfigure if one of the gets damaged. Now another topology we call as tree topology. A tree topology combines the characteristics of linear bus and star topology. In tree topology, group of star networks are connected to their linear bus backbone. Twisted pair cable is commonly used by tree topology. Tree topology is also called hierarchical topology or hierarchical structure. Actually, we got the diagram tree topology, but actually, you can see a lot many topologies are there involved. For example, if this device get connected to this device, and with that cable, this device also get connected. Means if for example, if I have a paint, then will tell you, might show you. For example, I think okay, it's not working. Okay, if for example this cable, if this cable gets connected to this device NIC, and if this cable gets connected to that cable, for example, if I'm talking about the bus like this, uh, if this device get connected with many more, if this device get connected with many more, if this device get connected with many more, then it will be formed as a tree topology. Means one stem is there and all the branches are following that network. That's the reason we're known as tree topology. Tree topologies combines the characteristic of linear burst and star topologies. Mean bus topology and star topology, it combines the characteristics, and you can even see the characteristics of star and bus. In tree topology, group of star networks are connected to their linear bus backbone. Twisted pair cable is commonly used for tree topology. Tree topology is also known as hierarchical structure. Advantages: point-to-point wiring with each device, easy to detect faulty device, since so many devices are connected with each other, so a user will have the access to everyone, so can understand which one is not working. Easy to expand a network. More and more network we can expand, and more difficult to configure as compared to other topologies. First step is to configure that, and it's ending with the big difficulties. Fault in the backbone affect the entire network. If one linear bus cable get faulty, then whole network will get damaged. More expensive than other topologies. Overall length in each segment is limited by the type of cabling used. Okay, the final one is hybrid topology, and hybrid one is again a big chain of topologies. Many topology you will find in the hybrid. It is hybrid is combination of different network topology. It is also known as special topology. This topology is used for corporate offices to link their network, the internal LANs, together while adding external networks together wide area networks. So not only internal LAN, but with these devices you can get access of external LAN also. External WAN, the external connection. So this is what the beneficial thing of hybrid topologies are. So now the advantage are useful for implementing large networks, handles larger volume of traffic, easy to detect and remove faulty devices. More cabling is required as compared to all other devices, all other topologies, which is disadvantage. More expensive than all other topologies. Complex structure, MAU is required. Installation and reconfigure is difficult. So MAU is multi-station access unit. It is required for hybrid, and multi-station means, for example, this network having this station and then hub, and then this get connected to here, then this computer getting and distributing data from here to here. So many multi station access units are there to finding out. So this is hybrid topology, a combination of many network, and then tree is also kind of that, but trees follows like one stem is there and the branches are connected with each other. So these are the topologies, very important in the networking field to learn about. These are basics of networking and essentials. Hope you learned something about topology. We will discuss about more of network essentials. Hope you able to get points clear about topologies. Thanks for watching.